The diagram here shows the exactly typical IP audio system, that the system includes what are the parts that are included in the system. The first, whatever the white signal that is captured by the microphone, that then that signal is voice signal is converted into the audio, that particular signal is converted into the electrical signal, that is audio signal by the wire. After that we are digitizing and compression is done on that audio signal. After that timestamp process is done for the purpose of converting that audio signal into the IP addresses. After that IP address allocation is done, where routers are interconnected and IP packets are done. After that, in the receiver we are having IP receiver section. After that, time sequence process, we have done time stamp process in the transmitter. Here in the receiver we are having time sequence process. And audio converter section means whatever the electrical signal, audio signal we are having, that we are converting into the voice signal by using the loudspeaker, and we are providing, or we are whatever the signal that is reaching to the people by using the loudspeaker. This is what is the typical IP audio system. What are the different blocks they are present in this IP audio system that we have seen now. Let us discuss in detail about this IP audio system. The audio signal that is converted into the IP packets, this is what we have called as a IP audio system. Thus, the typical audio system we can see the diagram here. This transmitter system consists of audio signal digitizer, signal compressor, timestamp that is applied there, and IP address is also done. IP packet that is transmitted on the packet switching network like the internet. Okay, the audio system shown in this diagram you can see is a simple monaural audio system. It is also known as single track audio system, where one mic and one loudspeaker is involved. Okay, audio recording that can be done in monaural, that is mono audio, is only a single loudspeaker. Stereo L and R channels, 2.1 stereo with one LFF, that is low frequency enhancement, that is one that is done here. And after that 3.1, that is pro logic. It is a surround sound system that adds an additional audio channel for the central speaker that is located in the front LR center, and one LFE speaker. 5.1, after that we can say that is surrounds the sound system, LR center, rear left, rear right, and rear LFE speaker is introduced here. And after that 7.1, that is it surrounds the sound system, that is LR center, rear left, rear right, top, bottom, and one LFE speaker. All these things are involved in this particular IP audio system, and audio recording can be done in this format. It surrounds the sound system, that is a reproductive of audio signal that surrounds the listener with the sound that is provided from the multiple loudspeaker locations also. After that, audio signal processing in block diagram includes the different things, that is audio signal is filtered first. After pre-emphasis and de-emphasis is done here, compounding and expanding of the audio is also done. Noise deduction process is done here. After that, audio digitization. Digitization is nothing but quantization, sampling and quantization. In sampling, we are converting the audio signal into the digital or discrete form, and quantization converts the discrete form into the digital signal. Digital compounding is done, which is a part of quantization. Audio format conversion, that is transcoding, is also done here. After that, audio compression, we are doing all these processes in this particular block diagram for the purpose of IP audio, that is converting the audio analog audio signal into the, or converting the audio signal into the IP packets. Analog filtering is a process which changes the shapes of an analog audio signal by restricting the portions of the frequency spectrum. Here in the filtering, higher frequency components of the amplitude that is increased in pre-emphasis process to overcome the noise and attenuation in transmission system, while compounding process is used to reduce the amount of gain of an audio signal for the larger input signal, irrespective of the less or loud sound signals. Okay, after that this process of compounding that must be reversed at the receiving end, and it is known as expanding to recover original audio signal. Means first we are use digitizing, then we are recovering the signal, we are getting the original audio signal at the receiver side. For the purpose of pre-emphasis, that pre-emphasis and de-emphasis process in the transmission section is done. In that pre-emphasis, whatever the signal we are getting at the loudspeaker, whatever the signal we are getting at the mic, that is filtered at 300 to 3300 hertz. After that high frequency signal we are getting here, pre-emphasis, in the pre-emphasis signal, whatever the signal we are having, that we are getting at the emphasized signal at the output of this particular block. And after that, whatever this emphasized signal is given to the de-emphasized section, we are amplifying this particular signal, and we are giving the signal to the loudspeaker, so that whatever the signal, original signal was received, that we are getting at the output of this, or at the receiver section, for the purpose of listening the signal. And in the compounding process, whatever the process we are performing, that is compounding, in that whatever signal we are getting at the mic, that audio signal is first filtered by using the same filter, that 300 to 3300 hertz. After that, whatever the signal, high volume signal that we are getting, we are using the transmitter compounding section, and compressed signal we are getting at the output of that particular transmitting compounding section, and this is given at the receiver's expanding section. After that, whatever the signal we are getting at the output of this, that is expanded signal. This expanded signal we are giving to the amplifier section, which amplifies the signal, where we are using the volume control to the amplified section. And after that amplified section, the amplified signal we are getting, that we are providing, or we are transmitting that signal to the loudspeaker, for the purpose of getting output of that particular this particular compounding and expanding audio signals. After that, audio signal that is digitized here, audio signal we are digitizing here, that is A to D conversion is done using the PCM here. Here dither, that is a random signal that we are adding to an analog signal during the digitization process, for the purpose of reducing the effects of quantization noise that occurs at the low levels. Okay, this dither, that is a white noise signal. Audio conversion that is done here, that is audio signal of the format MP3 is then changed to the another audio file format AFF. This is also known as transcoding process. After that, we are performing the audio compression. What is audio compression? The audio compression process, the audio signal is encoded in such a way that the smaller amount of information elements are they are reduced to the bandwidth. A bandwidth reduction is done, that is required for the purpose of representing and storing or transmitting the audio signals. The audio compression coder and decoder, they analyzes the input audio signal and remove the signal redundancies and sound details that cannot be heard by a human. Few coding processes, they are waveform coding, perceptual coding, voice coding, and audio compression technique. We can call it as lossy audio compression technique and lossless audio compression technique. The lossless compression technique that analyzes the data or the media signal and produces a new file format that can be converted back to its original audio formats. Okay, in lossy compression technique, that reduces an amount of information by converting it into the another format that represents the initial form of an audio signal information, but it does not guarantee that exact recreation of the original signal when it is expanded back from its compressed signal. Okay, this is how audio compression is done for the different purposes here, for the purpose of sending the audio over a channel. Waveform coding technique we are using. After that, waveform coding, it means that it consists of an A to D converter and data compression circuit also. Waveform coders we are using here, they are capable of compression and decompression of the signals like voice signal, music signal, modem signals, and fax signals. We are using compression and decompression of these different signals. After that, waveform coding results into larger media file communication and higher data rates, they are compared to the perceptual coders. This is how we are using the waveform coding techniques. The next coding technique we can see, that is perceptual coding. The first coding technique we have seen is that was waveform coding. Now let us see what is perceptual coding. The perceptual coding, it converts the information into a format that matches the human senses ability to perceive or capture information. Okay, using this, it would not be necessary to send the signal that cannot be heard even if the original signal that is contained multiple audio components. Okay, this coding that uses the frequency masking and temporal masking also. Frequency masking is the process of blocking, removing or ignoring the specific frequency component of a signal, and temporal masking is the process of blocking, removing and ignoring the specific components of an audio signal that occurs in a temporal that occurs in a specific time period or the time sequences while sending that information signal. It means that the compression process that may remove some audio information that the listener cannot hear. Also, compression process that may remove small sounds that occur directly after the louder sounds, that is temporal masking. The compression process that may also remove low amplitude signal that occurs simultaneously with other frequencies also, frequency masking. And compression process that may also ignore the small changes in the sound levels. This was the perceptual coding technique we have seen. Now next let us see the voice coding technique. Voice coding technique, it is a compression device which consists of speech analyzer that converts the speech audio into the different component speech parts. Thus, the speech decoder recreates the speech parts back into their original speech signal. From voice coders, they are used to compress and decompress the video signal as we will see now. As you can see in the diagram, that is digital speech compression that using the voice signal. Here hello world that is digitized in a given example. Okay, it analyzes and then the compressed output from code block that is available finally. This was simply the voice coding technique. Till now we have seen the different audio compression technique. First was waveform coding, then perceptual coding, and then we have seen the voice coding. Now let us see the next point, that is TCP IP and multimedia protocol stack. Here, TCP IP and multimedia protocol stack. Let us see what is TCP IP model. Is a four-layered structure that is resting on common hardware platform. It was initially developed for DARPA and sometimes it was called as DARPA model, DARPA model. TCP IP model that has standard that are defined and described in request for comment RFC documents. The layers in the TCP IP model, as you can see in the diagram, that is application layer is first. This application layer that refers to the standard network services like HTTP, FTP, telnet, as well as communication methods. They are used by various applications and different programs. Also they defines the compatible representation of all the data. Okay, next layer, we can see the transport layer. The transport layer manages the transfer of data by using the connections oriented, that is TCP, and connectionless, that is UDP. Connection oriented and connectionless, that is TCP and UDP transport protocols. It manages the connections between the network applications here. Next we can see is internet layer. The internet layer manages the addressing of packet and delivery of packet between the different networks. The fragments packets so that they can be dealt with by lower levels of layers, that is network interface layer. Okay, internet layer fragments the different packets so that they can be able to deal with the network interface layer. After that, the network interface layer we can see in the diagram. The network interface layer delivers the data via physical link, that is internet, to the most common link level protocols. It provides the error detection and packet framing here. Okay, the complete multimedia protocol stack we can see that consists of RSTP, media negotiation, that is call control, TCP IP, link layer, physical layer, SAP, RTP, different applications layer, lightweight sessions, and all these things are considered in a multimedia protocol stack. Now let us see what is actually the internet protocol for the audio. As you can see in the diagram, that is IP packet transmissions. The internet protocol, it is a principal communications protocol that is used for layering the datagrams, that is packets, across an inter network using the internet protocol suite. It is responsible for routing the packets across the network boundaries. It is a primary protocol that establishes the internet. Okay, the IP is a primary protocol in the internet layer of the internet protocol suite, and it has the task of delivering the datagrams from the source host to the destination host solely based on the addresses. For this purpose, IP defines the different addressing methods and structures for the datagram encapsulation. Here, audio IP packet that is transferred from one route to another route, thus the source to destination journey that is done by the IP audio packets through the network layer devices known as the router. After that, the transferring audio IP packets through the packet switching network that include different point, transmission delay, packet jitter, packet loss. Thus, the different types of control processes that are used for that includes the different types of control processes that are used, that includes the guaranteed two-way control signals using the TCP or best effort directional commands using the UDP. Also, in addition to this, the basic packet control message, additional relative packet time indicators, they are added in each and every message using the RTP, that is real time transport protocol. The source and destination router and packet switching network and IP audio communication that we will see, that we can see in this particular diagram. The first one XPC, that is source. After that, destination is Y. Then you can see the router packet, router, then packet, then switching networks and IP audio communication system. Everything you can see in this diagram. Let's discuss the next point, that is TCP, that is Transmission Control Protocol for the purpose of audio. This TCP communication, it coordinates the transmission, reception and transmission of packets in the packet switching network for the purpose of ensuring reliable confirmed communication between the client and server, as you can see in the diagram. The TCP protocol that coordinates the division of data information into the packets, then adding the sequence number and maintaining it, then flow control, then error detection and error correction, and then retransmission of lost packets. Everything can be coordinated by using the TCP protocol here. As you can see in the diagram, this is the diagram of TCP packet transmission. TCP that uses the IP protocol at the network layer. Okay, typical TCP handshaking signals between the source and destination nodes on the packet switching network that communicates in the form of client server communication model. Okay, as we have seen in the first diagram, client server communication diagram, there is handshaking between the client server, means there is synchronization between the client and server, then server will again send the acknowledgement. Okay, as you can see in this diagram, first client will send the synchronization message to the server. Server will send again the synchronization message that was sent by the prior plus acknowledgement to that message. Okay, after that client will again send the acknowledgement to the server. After that, then there will be the communication between the client and server, which is called as acknowledgement. It will be acknowledged by the client and server both. In this way, there is a handshaking of the information between the client and server. As here, the typical TCP handshaking we have seen between the source and destination node on the packet switching network that communicates in the form of client server communication model, as I told before. This particular TCP communication that includes the different processes. It consists of connection establishment, then data transfer, then connection termination. Okay, all these processes are done in the TCP packet transmission for the purpose of transferring the data in between the client and server. The next thing we can see here, there is UDP, that is user datagram protocol for audio. These are different types of protocol that we are using for the audio. This UDP, it is a transport layer protocol which coordinates the one-way transmission of data in a packet data network. It coordinates in the different form, that is division of files on block of data information into the packets, okay, or allowing reception end to receive and sequencing the different packets, recreating the original data files or block of data which was sent by the transmitter. UDP header overheads is lesser compared to the TCP header. UDP, it does not provide any guarantee of data delivery through the network, but it is a faster than the TCP communication. Okay, it is a faster protocol than the TCP protocol communication. Next, we can see the real-time transport protocol, that is RTP for the audio. The real-time transport protocol RTP that defines a standardized packet format for delivering the audio and video over the IP networks. RTP, it is used extensively in communication and entertainment system that involves streaming media such as telephony, video teleconferencing applications, and television services and web-based push-to-talk features also. The RTP here, it is used in conjunction with the RTP control protocol, that is RTCP, while RTP carries the media streams, that is let us see example audio and video. RTCP here, it is used to monitor the transmission statistics and quality of services, and it aids in the synchronization of multiple streams. RTP, it is originating and receiving on even port numbers and associated RTCP communication that uses the next higher odd port numbers also. RTP here is one of the technical foundation of voice over IP, and it is in this context it is often used in conjunction with the signaling protocol which assist in setting up the connections across the network. Let us discuss the next point, that is IP audio communication processes. It processes includes the different points, or the different processes we can say it as. First is packet buffering, then protocol operations, then audio streaming, then stream thinning, audio synchronization, file downloading, and progressive downloading. This is what IP audio communication processes means for the purpose of communicating the IP packets or the internet protocol audio packets in communicating that packets, whatever the processes are needed, that is packet buffering, protocol operations, then audio streaming, stream thinning, audio synchronization, and after that file downloading and progressive file downloading also. Now let us see one by one in detail. First is packet buffering. The packet buffering here, it is the process of using memory space to storing the packets that are awaiting transmission, for storing the received packets in a typical packet switching network between the sender and receiver communication. As you can see in the diagram here, packet buffering process is done where media server system we are having first, the it is whatever the packet, this media server system is converting into the packet, that packet IP packet switching that packets are given to the IP packet switching network. One packet is sent with the delay 1, then delay 2, delay 3, and some of the packets can be lost in this process. After that lost packets, they will be lost by this data, whatever the data in that packet, that will be lost. Buffer memory section, all these transferred what we can transfer packets that were sent or transferred by the some delay, that is delay 1, delay 2, delay 3, as we have seen now, with the different delays. Why delay 1, 2, 3? That is different delays are applied, not applied, different delays are have been done, means while sending that packets, the packets is sent with the some delay, that's why delay 1, 2, 3. Whatever the packets have been sent, that packets are stored in the buffer memory section, and after that by the buffer memory section, all the packets they are sent to the IPTV, that is viewer system, that is with the media player, using the set where we are using the set top box. As you can see in the diagram here, the packet buffer, they are temporarily stores the data before providing it to the media packets. It also provides the time that is necessary to time synchronization the packets and to request and replace the packets that have been lost during the journey from source packet switching network to the destination. After that, next is protocol operation. It is a blocking or restricting of the transmission of data packets and that contains the specific types of protocol. For example, if UDP protocol is blocked, then it restricts the access of streaming media. This to overcome the protocol operation, UDP is embedded into the another protocol sub as a TCP along with the IP that can pass through the firewall easily. The next process is audio streaming. What is audio streaming? It is a continuous transfer of audio information that is seen through a packet switching network that can be represented in the audio frequency band. Next, clients they receive the different clients they are using this. They receive the data stream after a short buffering delay. Then it decodes the audio and then play it for the user inherent audio streaming system. The 2 kbps data rate for voice or telephony quality speech and hundreds of kbps data rate for the audio file quality music. The audio streaming processes that may use the automatic rate detection or the manual rate detection here for the controlling the transmission rate of audio streaming. After that, the next process we can see the stream thinning. What is stream thinning? It is a process of removing some information in a media stream for the purpose of reducing the data transmission rate and increasing the speed of communication. Currently, the audio thinning is supported only with the MPEG-1 and MPEG-2 audio data, low bit rate audio data that cannot be thinned. The thinning of audio data that occurs in two stages. Stage 1 that is audio thinning and stage 2 that is audio thinning. In the two stages, audio thinning two stages, first stage and second stage. In the first audio thinning stage, if the audio data that has stereo channels and stage 1 thinning that converts this to a mononeural audio data, and in stage 2 audio thinning the audio data that can be thinned by reducing the audio data rate until the amount of transmitted data that does not exceed the available bandwidth of the streams which will work which works the player receiving an audio packet stream. Here MPEG-1 encoder that gives the audio thinning system up to the minimum 32 kbps and MPEG-2 which gives the minimum of 8 kbps. Okay, in this way in stream thinning we are using the two audio thinning processes. In the first audio thinning processes we have seen we are using the stereo channels, and in second we are thinning it for the purpose of reducing the audio data rate until the amount of data that we have transmitted that does not exceed the available bandwidth, so that for the purpose of making it to the same within the available bandwidth. The next process we can see after that, that is audio synchronization. In the audio synchronization adjusts the timing of audio signal for the purpose of matching the presentation of other media like PPT slide presentation, then images or videos. The audio packets are synchronized with the video packets. In this way, what they are multiplexed channel that can include the program clock references, that is PCR timestamp, for the purpose of allowing all the media streams to be remain time synchronized with each and other during the sending, transmission and reception of the process. This is audio synchronization. After that, there is a file downloading. It is a process of transferring the entire audio file media server to the IP audio player section before audio playing that can begin. Okay, next process is progressive downloading. In the progressive downloading, it is a process of transferring of file or data in a sequential manner that allows for the using of portions of the audio package data before the transfer is completed. For example, the HTTP streaming, in which it manages the sequential transferring of media files through an IP data network using the HTTP command. This will allow you for the purpose of media players to be played before transfer is complete.